Hello everyone, I am Mrs. K. Vanitha, Assistant Professor working in the Department of EC at K.S. Rangasamy College of Technology. Today we are going to see the lecture on Ipv4 addresses in the course Computer Networks under the module Network Layer. So first of all, Ipv4 addresses. Ipv4 addresses is a 32-bit address which defines the connection of each device to the internet. Address space is the total number of addresses used by the protocol. Since it is of 32-bit address, it means that 2 power 32 address space are available in the Ipv4 addresses. Can be represented by binary notation, dotted decimal and hexadecimal notation. This 8-bit number is represented with 128. Between decimal numbers there will be a dot, so that it is called as dotted decimal notation, which further can be represented with hexadecimal notation. Hierarchy in addressing. 32-bit Ipv4 address is also hierarchical. The first part of address is represented with a prefix. It defines the network. Second part is suffix. It defines the node. The prefix defines the network and suffix defines the node. So if we have 32 bits, n bits are represented with prefix, 32 minus n bits are represented with suffix. Classful addressing. In the Ipv4 addressing will be further divided into classful addressing as well as classless addressing. An Ipv4 address was designed with the prefix length, fixed length prefix, n is equal to 8, n is equal to 16, n is equal to 24. And it also, the whole address space was divided into 5 classes, class A, B, C, D and E. Occupation of address space in classful addressing. The address space, that is 2 power 32 address space, will be further divided into 5 classes, class A, class B, class C and class D. If it is represented with the binary number, if the first bit is 0, then it represents class A, 10 class B, 110 class C, 1110 class D and 4 ones. The first 8-bit number represents 4 ones, so that it is class E. Class D is mainly used for multi-class addresses. And if you represent it with dotted decimal notation, class A, if the first decimal number, that is in the dotted decimal notation, have the value that is 0 to 127, it is class A, 128 to 191 class B, 192 to 223 class C, 224 to 239 class D, 240 to 255 class E. Address depletion. The classful addressing has some absolute called as address depletion. To understand the problem, let us think class A. Class A will be assigned to only 128 organizations in the world. So most of the addresses are wasted. Class B is also designed for mid-size organization, but many addresses in this class also remains unused. Class C will be completely different, that is a number of addresses in this block will be 256, which is very small. Most of the companies are uncomfortable with the blocks in this address class. So that the supernetting and subnetting was derived. To alleviate the address depletion problem, 2 categories were proposed: subnetting and supernetting. In subnetting, class A and class B block is divided into several subnets with a larger prefix length than the original network, each subnet. Supernetting which is devised to combine several class C blocks into larger block to be attractive to organization that needs more than 256 addresses available in the class C block. So in the subnetting, class A and class B blocks are larger, so that it is divided into several subnets. And supernetting, multiple number of class C addresses are combined together, which will be available to the user. Advantage of classful addressing, where the prefix length is fixed. So classless addressing, subnetting and supernetting in the classful addressing did not really solve the address depletion problem. So with the growth of the internet, We need larger address space to be the long-term solution. But the short-term solution still uses IPv4 addresses, but it is called classless addressing, where the class privilege was removed. The classless addressing, variable length blocks are used. We can use one block address, two addresses in a block, four addresses in a block, or 128 addresses in a block, and so on. The number of addresses in a block needs to be the power of 2. We can have prefix length from 0 to 32. And smaller, if the size of the network is inversely proportional to the length of the prefix. A smaller prefix means larger network, larger prefix means smaller network. Prefix length slash notation. Prefix length n is added to the address separated by a slash. It is informally given by the notation slash, but formally represented with CIDR, classless inter-domain routing. So it is represented with your IP address of 32-bit in a dotted decimal notation with the slash notation as the prefix length is represented. Furthermore, with the prefix length, we can extract three information. One is first address in a block, last address in a block, and the number of addresses in a block. So, if the number of addresses in a block can be found by capital N is equal to 2 power 32 minus N. To find the first address, we keep the N leftmost bits and set 32 minus N rightmost bits to 0. To find the last address in the block, we keep N leftmost bits as such and set 32 minus N rightmost bits to 1s. For example, a classless address is given with the IP address with the slash notation, that is CIDR 27. We can find the above three pieces of information as follows. The number of addresses in a network 2 power 32 minus N, which is equal to 2 power 5, 32 addresses. The first address can be determined by keeping the first 27 bits as such and changing the rest of the bits to zeros. That is 32 minus 27. 5 bits to zeros. And again we convert the binary number to the decimal number. So from the decimal number we convert it into the binary number. We find the first address in a binary pattern. So finally we convert it into the decimal number. The last address can be found by keeping first 27 bits to as such and keeping the rest of the bits to ones. So first of all we convert this dotted decimal notation into its binary equivalent and we keep the first 27 bits as such, and that is 32 minus 27, 5 bits, last 5 bits to ones, and this last 5 once again these binary bit pattern will be converted into dotted decimal notation so that we can take the last address in the block. The network address, the first address is nothing but a network address. It is particularly important because it is used in routing the packet to the destination network. It will tell to which network the packet should be sent, from which interface the packet should be sent. Next, block allocation. For the proper operation of CIDR, two restrictions need to be applied in order to allocate the block. That is, first one is the number of requested addresses needs to be the power of 2. Capital N number of addresses which is equal to 2 power 32 minus N, or subblock, for subblock N is equal to prefix length 32 minus log 2 capital N number of addresses in a block. Second one is the first address needs to be divisible by the number of addresses in the block. So with this we can design subnets. If the number of addresses in a block is capital N, prefix length is small n. The assigned number of addresses to each subnetwork is capital N sub and the prefix length is small n sub. The following step will be needed to carefully design the subnets. Number of addresses in a subnetwork will be the power of 2. The prefix length for each subnetwork should be found by using the formula. Prefix length for each subnetwork in a block, that is 32 minus log 2 capital N. Capital N is the number of addresses in the block. The starting address in each subblock should be divisible by the number of addresses in that block. So this can be achieved by selecting the first assigned address to larger subnetworks. So larger subnetworks will be given priority. Yes. So with this information we can design subnetworks. An organization, a problem. In this problem, an organization is granted a block of addresses with the beginning address with the slash notation 24. The organization needs to have 3 subblocks of addresses to use in its 3 subnets, 1 subblock of 10 addresses, 1 subblock 60 addresses and 1 subblock of 120 addresses. Design the subblocks. So then there are 256 addresses in the block, which means that 2 power 32 minus 24, the slash notation. So which will be 256 addresses in the block from 0 to 255. The first address is 0 and the last address is 255 in a total block of addresses. We need to assign addresses to subblocks starting with the largest to the ending with the smallest. So number of addresses in the largest subblock will be, here we have 3 subblocks, 10, 60 and 120. The largest subblock is 120. So we need to assign addresses to the first of all the largest subblocks, that is 128 addresses. The subnet mask, that is prefix length of this block, will be calculated by 32 minus log 2 128, which is equal to 25. So 25 and since we need 128 addresses, 0 to 127 will be assigned with the prefix length that is 25. The number of addresses for the second largest subblock 60 will be in the powers of 2, so that's 64 from 64 and the prefix length will be 32 minus log 2 64, which is equal to 26. So 64 addresses from 127 is nothing but 128 with the 64, so 191. And the next addresses, number of addresses in a smaller subblock called as 10 will be allocated with 16 since we need to have the power of 2, and the subnet mask or the prefix length will be calculated by 32 minus log 2 16, which is equal to 28. The first address in the block is from this 190 to 191, from 192 with the prefix length 28, and the last address can be 192 plus 16 207. So in this way you can calculate the subnets in a large block of addresses in a block. So with this we can have MCQs. And IPv4 address is how many bits? IPv4 addressing prefix length defines. The answer will be IPv4 is of 32 bit. Prefix will define the network and suffix will define the how many classes in classful addressing. Suffix will define the node and 5 classes: class A, class B, class C, class D and E. The drawback of class A addressing is too many addresses are wasted. Which class was designed for mid-size organization? It is class B. The class A addressing, maximum number of hosts per network will be, and the classless addressing, number of addresses in a block must be, so 1 to 256, and it is the power of 2. Number of addresses in the block must be the power of 2. The slash notation, the classless addressing, otherwise called as informally. The first address in IPv4 block is otherwise called as, it is CID, first address is network address. So we have seen IPv4 addresses and how to design subnets in a large block of addresses given, and its related MCQs. Thank you for your patient listening.